All right. Good morning, good afternoon, good evening, and welcome to the Qatar Open Innovation Program webinar. This webinar is a partnership between QRDI and Es'hailSat. I'm very excited to be your host for this session. Let me introduce myself. My name is Abdul Haq Bal'idi. I am a QRDI manager in charge of the Open Innovation Program. My distinguished guests and panelists today is Mr. Nicolas Stefan from Es'hailSat. Nicolas Stefan is an international satellite ground system professional with 22 years of experience. Nicolas has been involved in space program development and management, ground system and satellite procurement, ground system and satellite operations, as well as business development and general manager of SME organizations. Nicolas has been working for Es'hailSat as executive director in satellite operations for more than 8 years, building from the ground up the satellite operation department of the company. Leading a team of satellite operation managers and engineers, he is committed to provide the most resilient and safe satellite and payload operation service possible, always with the end customer in mind. Prior to joining Es'hailSat, Nicolas has served several management roles in the Middle East and Southeast Asia and Europe, always around the satellite operation business. Regarding the agenda of today, Regarding the agenda of today, I will start by introducing Qatar Open Innovation Program. Then I will hand over to Es'hailSat to talk about the Open Innovation Call titled the Remote Telemetry Monitoring and Geostationary Satellites. Then I will explain how to submit a proposal. We will reach to the Q&A session and end the webinar. Before describing the Open Innovation, I would like to say some words about the QRDI, which is Qatar Research Development and Innovation Council. It was established in 2018, representing a new milestones in Qatar Research Development and Innovation agenda. The Council's first mission was to develop a national strategy that would optimize RDI activities and help realize the country overreaching goals and ambitions. The Council accomplished this mission at the end of 2019, having drafted the Qatar Research Development and Innovation Strategy 2030. The Council brings together prominent national and international figures from government, industry, and academia, and draws on the wealth of knowledge and expertise of individuals from various disciplines. One of the first programs launched by QRDI is the Qatar Open Innovation Program. The Qatar Open Innovation Program aims at connecting opportunity owners. Opportunity owners in this case are large local enterprises and government agencies to the local and global innovators. So in the frame of this program, we work with large local enterprises and government agencies to identify the area where they want to pilot innovation in order to enhance their performance and competitiveness. So after framing the call, we work together with the large local enterprises and other partners to publish the call all over the world, and then receive your proposals in order for you to pilot these innovative products inside Qatar. Through this program, we will facilitate the engagement of the innovators with the large local enterprises. And we will fund the initial pilots to be developed inside Qatar. what's in the program for you as an innovator. So you will gain access to funding for pilot development, potential commercialization agreements with the large local enterprise and government agencies, facilitated company registration process. You gain access also to local incubators and accelerators. And last but not least, gain access to Qatari and GCC markets. Here are some examples of the calls that we published and with different partners. These are some large local enterprises in Qatar: Kahrama, Hassad, Milaha, Baladna, Uridu, Sidra, Es'hailSat, GWC, Aspire, and we have 2 government agencies as well. Since we launched this program, we started this program, we published 21 open innovation calls. We awarded 8, 4 are under evaluation, and the rest are still live, like the Es'hailSat 1. Now I will hand over to Nicolas to talk about the Es'hailSat open innovation call. Nicolas, the floor is yours, please.
Thank you, Abdelak. Thank you very much for the presentation. Thanks everyone for joining this webinar and for your interest in this project. So let me introduce you a little bit Es'hailSat first to place the ground. So can you move to the next slide, please, Abdelak? Thank you. So for those who know us, it's going to be pretty clear. For those who don't, Es'hailSat is a satellite operator. It's a Qatar state-owned company. Okay, we belong to Qatar Investment Authority, and we are operating 2 geostationary satellites for the country. Both satellites are broadcast, and I'll talk about them in a minute. But the company has been established in 2010 as a spin-off of the ICT Qatar, which is now the Ministry of Telecommunication. And the first satellite was launched in 2013. In 2018, we launched a second satellite, SL2, also for broadcasting activities. And in 2019, we inaugurated our teleport in the north of Qatar, about 75 kilometers outside Doha, where we host a lot of from small to large antennas to communicate with our satellite, but not only with our satellite, with other satellites. The main mandate of Es'hailSat is to provide broadcasting capabilities to our main Qatari stakeholders, government and Qatari entities, but also international customers. Next slide, please, Abdelak. Thank you. So the aim of the vision of Es'hailSat is within the Qatar National Vision 2030, and to become one of the world-class satellite operator, a regional one first, and then broader. So we are building up our capabilities. As we have seen in 2013, we had our first satellite, 2018, the second one. We're thinking of a third one right now, so the mission is being designed. We strive to provide advanced satellite services to the community, the Qatari stakeholders and commercial customers. One of our main customers are Al Jazeera and beIN Sports. Next, please. So next, please. So SL1 is the first satellite launched in 2013. Here you have, for illustration purposes, you have coverage. It's mainly a KU band broadcast satellite, okay, covering the MENA region, from Morocco pretty much to the Arabic Gulf, covering Saudi and all the Middle East and North Africa region. And next, please. The satellite was launched in 2013, as I already mentioned. It was built by a company used to be called Space System Laurel from Palo Alto, California. It's now known as Maxar. The satellite is based on a typical SSL 1300 satellite bus. It's a pretty big brick satellite. We're talking about 5 tons wet mass and about 3.5 tons dry mass. It has K-band transponders and K-band transponder. It had a dual mission as well, a governmental mission and a commercial mission. Next, please. The second satellite is Es'hailSat. It was launched. Next, please. It was launched to the end of 2018. Next, please, Clark. Thank you. So the satellite coverage is very similar to the first one. The major difference is that we have an uplink in K-band in spot beams, as you can see on the left-hand side of the coverage. So these beams are for illustration because we can actually move them. Yes, we can uplink in K-band to reduce jamming of the signal, for instance, so it makes our communication more secure with our customers. Next, please. The satellite this time was built by Mitsubishi Electric from Japan. It was launched from Florida and by SpaceX Falcon 9 in end of November 2018. And the coverage, as I mentioned already, is pretty much the same than the first one. And also the type of mission is broadcasting, so what we call direct-to-home television. On that satellite, we also have VSAT, so very small aperture terminal missions, okay, that allow our customers to uplink data, okay, so and receive also data on their side, not only broadcast. Next, please. So the call for innovation today is for one of the 2 satellites for now, but we plan, if we go live with a commercial offer, to have it for both. Okay, so can we move to the next place? Next slide. Thank you. So we have two goals on that innovation call. The first, but today we're going to talk about the short term. But we mentioned the long term because it provides you insight why we want to do it the way we want to do it, okay? And that's why we are putting the long-term goal as well next to a short term. However, we need to focus right now on the short term, just keeping in mind the long term. So our need is pretty clear. In case of we want to reduce the downtime in case of satellite anomaly. And the problem is that the teleport, as I already mentioned, is about 75 kilometers outside Doha in the middle of the desert. And therefore, the teams, they're not living there. They live in downtown Doha. So in case of anomaly, we have a pretty big constraint is that our team is far from site. And if there is an issue, the engineer on duty may not be able to answer any incident that may happen. Therefore, the team has to travel there. So the approach that we're looking at is to avoid these, to answer to this constraint, is to have a remote system that allow us to connect remotely, okay, and to perform analysis and support the team, the personnel on site with all the team that are in Doha without having to travel there. Okay, so we can save up an hour of travel time. And an hour in terms of anomalies on the satellite, it's a lot of money. So that's why we want to reduce that time. So the approach that we're looking at right now, it's a remote cloud-based monitoring system that will allow us to start investigation right away when something happens. So the typical scenario is we have a satellite control engineer that is 24/7 at the teleport. And when something bad happen, he calls the support, the on-call support, and the on-call engineer could technically connect remotely to this remote telemetry system, allowing him to analyze the data, see what's going on, and support the engineer on site to try to recover the situation. It will reduce the time of recovery and eliminate the need to send the team on site. One of the major benefits is that it will limit the outage by reducing investigation time, okay, and the finance, and reduce obviously the financial penalty that we would have to pay to our customers. And something that is extremely important and is priceless is the company reputation, obviously. So our competition, Es'hailSat is a relatively small and recent company if you compare it to other geostationary operators that you may know, such as Eutelsat, SES, Intelsat, or in Europe. These companies have 25 to 50 satellites flying. We have 2. So of course the resources are different, the capabilities are different because of this just matter of number of satellites they fly. And most of them have already remote monitoring solution, okay, that they have developed in-house and allow or they also have 24/7 team on site, depending on the policy that they choose, allowing to respond to any issues. Obviously, when you have 30 satellites flying, if you have a team 24/7 on site, I mean, you always have an issue on one of the satellites, so it makes sense to have a team permanently on site. Okay, they will be busy all the time. They will have to answer the calls. But for us, with 2 satellites, we don't have that many, so having the team on site wouldn't make financial sense. So that's why we're looking for this remote system that would allow us to monitor the satellite from home or from anywhere we are. When something happened. But why would like to have it on the cloud? Because you could say we could connect directly to remotely to the control center. Well, first, the control center is a secure network, and we don't want to allow connection from outside to avoid potential intrusion. That's one thing. But the second thing is that on the long term, need, we have received a mandate from our top management to use or to investigate the possibility of using AI and machine learning to predict potential failures and therefore reduce also outages. So because of that, it makes complete sense to have everything on the cloud. Okay, so the telemetry being on the cloud could be used by these AI and machine learning to perform a lot of data analytics, a lot of predictions, a lot of analysis that we won't be able to do on premises. So that would be the approach. The machine learning will allow us early detection of potential failures, okay, and help potentially the team to prevent them. Obviously, this is still investigation. We are in the early ages of machine learning and AI. So obviously that's, I would say, a long shot for now. But that would be the long-term goal if we put all this telemetry into the cloud. It will save the same thing as having that on the cloud. It will save the company reputation. And also it will bring the company at the forefront of innovation, because we don't know, as per today, any satellite operator for geostationary spacecraft that are moving their infrastructure to the cloud. To use machine learning and AI in satellite operation. That's, for now, it hasn't been done. So in 2023, there is a big event every year in Washington, DC. It's called the Satellite Show, and the 2 major technologies that were brought were machine learning and cloud computing. So that means that our competitors are also thinking about it, but so far nobody has, I would say, make the first step to move to machine learning and AI and cloud computing for satellite control centers in general. And we want to stay ahead of the competition. We want to take that as an advantage for the company. Next, please. So that was it for the introduction of this innovation call from our side. So I think, Abdelak, we're going to move to the Q&A, or maybe the presentation of the way for the attendant to apply for this call. So I'll hand it over to you.
Thank you very much, Nicolas, for your presentation. Yeah, so we will now I will explain how to submit the proposal. Meanwhile, I would like to remind you that you can use the Q&A function to send your questions if you have any. So how to submit a proposal? You connect to our website here, and you scroll down until you will find a lot of opportunities or calls. So you scroll down until you find the remote telemetry monitoring from Es'hailSat. You click on it, then it will open the proposal with the description of the proposal. Then you click on apply here. When you click here, it will take you to the website of our, or the platform of our partner, 9 Sigma, where you will see the same information. So you have the deadline is August 2, and you have also the different sections of the call. You can click on response. It will take you to the if you don't have an account with 9 Sigma, then you will have to create an account. Otherwise, you will just enter your username and password. It takes you back to this page where you click again on respond, and it will take you to the proposal submission page, where you will have to fill the different fields and click on the relevant box. I have here some advice to you. So please fill in all the fields of the proposal and tick only the relevant boxes. If you are not done yet, you can save and come back later. If you don't have time, for example, you will continue your application. After finishing the application, please click on the button submit. Otherwise, your proposal will stay in the draft status and it will not be submitted to us. The due date to submit proposal is August 2nd, 2023. That's all for the proposal submission. Now we reach the Q&A session. I will try to respond the programmatic questions related to the program, and Nicola will answer the questions, technical questions. So one question, could you please give a brief overview of the Cortex baseband unit and provide a link to the specs?
Sure. So the Cortex is a typical interface, a typical modem, if you will, or baseband unit that transform the RF signal to IT signal and vice versa. Okay, it's our link from the RF signal received from the antenna to the satellite control center, and that's one of the key components of a satellite control center. The Cortex is actually a name. Okay, it's an equipment that is developed by Zodiac Aerospace, formerly Safran Data System. Actually, Zodiac Data System, and now Safran Data System. And it's widespread in the geo satellite operation world. I mean, they have 90% of the market on the world. Okay, so the Cortex has a defined protocol. Okay, to communicate with satellite control center. You have a Cortex message, so we can provide obviously all the specs related to the Cortex message, but it's pretty standard, so you should be able to find them on Safran Data System website. If not, we can provide them.
Thank you, Nicola. Another question: does Es'hailSat has a budget on top of the QRDI financial involvement limit, because the request is for monitoring system on one side and AI and machine learning on another side?
So as I mentioned, we're only talking about the monitoring system right now. We're not talking about the AI and machine learning. Okay, so the call is not for AI and machine learning. It's only for the monitoring system. But we want you to keep in mind that we want to use that in the future. Okay, and that's why the cloud option is the best option, because the remote telemetry monitoring system could be a remote system connecting to our network. Okay, and allowing us to get the telemetry as well. That's not what we want, because we want the data to be available on the cloud, so we can use AI and machine learning tools from the cloud, from the typical cloud providers, such as AWS or Azure, to perform some data analytics on it. Okay, so that's the reason we want to present the long term, but it's not part of that call. So
Thank you, Nicolas.
Answer the question.
Thank you, Nicolas. Another question, is it possible to have the PDF format of the template for the response? Yes, we can provide you with the PDF format. However, the application should be through 9 Sigma portal, please. Next question is it connected to the internet?
Yes, the site is obviously connected to the internet. Absolutely, yes.
Okay.
Yeah, we have our own. We have 2 types of connections. We have a typical or regular broadband internet connection, and we also have our own fiber. Okay, that goes to the site. So we have a pretty large pipe that is coming to the site. So yes, we do have internet connection.
The Cortex is baseband is connected to the internet. Yes.
Sorry, the IT Cortex. I mean, with the IT Cortex. What do you mean? I'm sorry. Oh, the Cortex baseband, is it connected?
Yeah.
No, the Cortex is definitely not connected to the internet because it's too dangerous. Okay, in terms of security. So the Cortex is part of the closed network. Okay, and with no connection from outside. So we have different level of firewalls. I cannot obviously disclose here too much, but we can open a port. Okay. Of the Cortex. I mean, we will open a port of the Cortex, obviously, and then that port will be allowed to provide all the telemetry to the internet, obviously, when you need it for the POC. Absolutely.
Another question: if it's not connected, is there any internet connection available?
It is. It
okay.
I mean, the Cortex is, as so let me maybe rephrase if I'm not, I was not clear. So the Cortex is right now into a closed network. Okay, the Cortex have several telemetry ports. We can dedicate one or two telemetry ports to a connection from outside. Obviously, we'll have all the security in place with the firewalls to prevent anyone to enter. So it will be just a way to get the data rather than I mean, you won't be able to request anything on the Cortex. You won't be able to do anything. The data will just keep flowing.
Good. Thank you, Nicolas. Another question: do you have any preference of the cloud provider? Is it Microsoft Azure or Google Cloud?
We don't. We don't have any.
So this is the same question then. Is there an internet connectivity to the SMEs teleport?
Yes, so as I already mentioned, yes. And if I follow your question, once we have cleared the IP address, yes, you can access the Cortex from anywhere. That's the idea, because the idea is to send data from the Cortex to the cloud. So obviously you need to access them. So the idea is when you say you can reach the Cortex from anywhere, eventually yes, because the Cortex will be eventually, with the security in place, connected to the cloud.
Okay. Another question: will the event be available? Oh no, this is to me. So we are recording this webinar, and we can send you a copy if you need it. What you have said meant that we do not need HW locally?
So I would say the answer is dual here. It's yes and no. Okay. For the POC, indeed, you don't need. Okay. Now, there is one case that, I mean, in the design of the solution or the POC, you need to take into account that we can't have any gap in the telemetry. Okay, so that means if there is an internet disruption, internet connection outage, for whatever reason, we can't lose the data. So we need to find a solution, and I don't have the solution. I don't know. Okay, we need to find a solution to keep these data flowing. And if there is an internet connection outage, how can we do it? Maybe having a small server on site that is buffering the data and send them later. I'm just thinking loud. We don't have the solution right now, okay? But that's something that we may need to think for later. If there is we might have a need for a small piece of hardware on site, but it's not necessary, it's not mandatory, depending on the solution.
Okay, another question, do you have an estimate of the quantity of data to be managed?
That's a good question. Yes, yes, we do. I think we're talking about, I mean, I don't have the numbers in mind, to be honest. I can't remember exactly the numbers. Maybe Pietro can help me on that. But I think we're talking about something around 7 to 10 megs per day of data, because the data are not very big, but it's non-stop 24/7. Okay, so it's 7 to 10 megs per day or something like this. I can come back to you and give you a more detailed answer on that.
Thank you. Another question, do you accept a solution which requires having a hardware box on the side that is connected to the Cortex to get the data, process, compress, aggregate, format, and filter it before sending messages to the cloud? Or do you prefer to have this intelligence in the back end?
So it depends what is required. We prefer to have the maximum on the cloud because we can use it also as a disaster recovery mechanism as well. Okay, if you put a that's another long-term goal, if you will, that we will not express here, but so we're going step by step in this approach. But we have ideas for the future as well if this goes well. And therefore we prefer to avoid having anything on site, because it's currently what we have. Okay, we have everything on site, and we don't want to have too much intelligence on site. So the less we have, the better, and better to have everything into the cloud. Yes, as much as possible.
Another question, considering that Es'hailSat operates Cortex baseband units, which are the limitation of the Cortex neuron platform that made it not suitable for this use case. The Cortex neuron is advertised as providing the required service of cloud upload and analysis.
It's a good point. We haven't really, so the neuron is, if I'm not mistaken, because I'm not really an expert on that, is a software-defined radio piece of, I mean, is the codex, but digitalized into the cloud, if I'm not mistaken. So we haven't looked into that. For now, we have our codexes, okay, they are in place. So the easiest way for us is to connect to the codex and get the telemetry. But there is, for us, we didn't think about the Cortex neuron platform, but we're open to proposals.
Are there any specific challenges or limitations associated with the remote telemetry monitoring for geostationary satellites?
Yes, so there are many. But if I take the main one is telemetry monitoring. Telemetry from satellite are following CCSDS protocol. The CCS-GS protocol is a protocol, but it's also kind of a big framework, so you can adapt it the way you want. So each satellite has its own kind of tweak on the protocol. So you need to understand well the CCS-GS documentation to be able to document the telemetry. That's one of the main ones. The other one also is that it's 24/7, and I think in the we have requirements in the call for innovation to cost pretty much how much it would cost to run these on the cloud. We understand that some companies are proposing a similar solution for Earth observation satellite, but Earth observation satellites have a very short pass of 10 to 15 minutes, and therefore the amount of processing power is limited. For us, it's 24/7. And the number of points is, we're talking about 30,000 points. We're talking about 7,000 points per second that need to be documented. So yeah, it's a lot of processing power, and that these are the challenges comparing to Earth observation satellite or LEO satellite in general.
Thank you. Next question. Since Cortex is not ready to connect to the cloud directly, can the communication pass through a remote backend, then go to the cloud?
No. Well, the Cortex is ready. The Cortex is providing a TCP/IP interface, okay, to connect to anything. So you have an internet cable. So we have a TCP/IP protocol that provide the information to wherever you want to any network. So it can be a cloud, it can be a local network. It doesn't matter. It's a TCP/IP protocol. So it's ready to be connected anywhere we want. Okay. Now we just need to allow you to connect to the cloud to the Cortex by configuring the I would say the firewalls correctly. But yes, there is absolutely no issue to connect the Cortex to the cloud as long as the firewalls are configured correctly. If I understand correctly the question.
Okay. Next question: which protocol does the Cortex support for the communication?
So as I mentioned, the communication itself is TCP/IP. Okay. But the protocol, the Cortex has its own protocol for the data. So the TCP/IP encapsulates the Cortex protocol. It's a native protocol for the Cortex. That's available as well. We can provide you that, and it's well known in the industry.
This is here a long question. In case of an event on the antenna side, on top of the request to be informed anywhere, PC, smartphone, will it request specific interface to return commands to the antenna? Or does the local antenna team will be responsible for entering locally to the commands following the instructions of the Doha engineers?
Yeah, so as mentioned in the title of the call, it's a remote telemetry monitoring. There is no commanding. Okay, so we don't consider commanding at this stage. So you don't need to worry about returning any commands to the antenna or anything like this. You're just going to receive the telemetry from the Cortex, and that's it. You're going to receive TCP/IP packets from the Cortex on a regular basis.
The next question: can you confirm if the interface of the Cortex baseband units?
I think you mean could you provide me the specification in order to understand the required effort? I'm not sure what. Oh yeah, what's the?
Yeah, this is why I skipped it.
Yeah, okay. Cortex protocol.
So
okay, I think we can provide that. Yes.
Okay, can you confirm if the interface of the Cortex baseband units is Ethernet plus TCP/IP? Some of the baseband units employ serial interfaces or proprietary hardware, which would require additional hardware.
I think I already answered. Yes, it's TCP/IP protocol. Yes. So there is no serial interface on this one.
Okay. Another question, are you going to consider the cloud infrastructure costs?
So that's part of the call for innovation. There is a requirement as part of the effort of the POC with QRDI, I think it should be. I mean, it will be covered with this. Now, for the long-term operation, one of the requirements is actually to estimate the running cost of operating this remote telemetry system on the cloud. So that's one of the requirement, is to have this proper estimation, because as I already mentioned, for those that are running on LEO satellite, the cost of running those telemetry is limited because the number of telemetry points is limited. First, second, the time of the commutation is really limited as well. We're talking about 10-15 minutes per pass. Each pass is about every 90 minutes, so it's not much. So we're talking about maybe a couple of hours per day, tops. But for us, it's 24/7, and the amount of data that we're storing is also much higher, much bigger. So that's why we would like to have a cost estimate of how much. I mean, if it financially makes sense to have this remote telemetry monitoring system on the cloud or not. Because if we have to pay $200,000 per year just in running costs of the operation system, I don't think it's worth it.
Okay, thank you. Last question. Please confirm that you are looking to have a real-time dashboard for your engineers, operators with an automatic altering mechanism. Could you share at this stage the desired types of charts and examples of rules to trigger these alerts? Or maybe it will be shared later.
We will share that later, for sure. I can just talk a bit about it. Yes, so the real-time dashboard, yes, will have satellite, a geostationary satellite is handling, I was saying 7,000 plus telemetry per second. Okay, obviously we can't plot all this on one screen, doesn't make any sense. But we usually, the way, and once again, that's the way we currently work. It doesn't mean that it has to be that way. Okay. Right now we have what we call telemetry pages. Okay, and these telemetry pages represent a number of telemetry points, or telemetry what we call the parameter ID or telemetry ID on that page. So we can have like maybe 200 points on one page, or 100 points. We can have a mix of values and graph as well. We can, so it has to be flexible. It has to be able to be built by the engineers based on what he needs to see. But for now, we don't have. I mean, we are a typical, I would say, regular satellite operator for geostationary satellite, meaning that we don't have any exposure so far to the new technology on the cloud and how the new satellite control center would work on the cloud. For instance, I know that some companies are working on LEO. We have an idea. We saw some demo in the past how things are working, but we don't have any preference on how to present the data. However, we have a large number of data to be presented, so that's have to be taken into account. And yes, I mean, having 3 or 4 data on the dashboard, or even 10, that's definitely not enough, okay, for our operations. However, we can share with the awardee later how we can, I mean, what we can propose. But once again, we open, okay? We are not fixed something. If the awardee comes with a great idea of how to present the data, we are definitely fine with that.
Okay, so let me thank Nicolas again for his presentation and for answering the questions, and for Es'hailSat team for their efforts. I would like to thank everyone who attended this webinar, and I look forward to receiving your proposals and hopefully working with you to pilot your projects here in Qatar. Thank you very much again.
Thank you everyone for attending. Thank you.